Welcome to today's deep dive into a groundbreaking development from NASA, a near-light speed engine that challenges our very understanding of physics. In a realm where science fiction meets scientific possibility, this new design promises to revolutionize space travel and spark heated debates among experts. Imagine a propulsion system so advanced that it defies established laws, offering visions of interstellar journeys once deemed impossible. Today, we'll explore the core concepts behind this innovation, examine its potential impact on space exploration, and weigh both the excitement and skepticism it has generated in the scientific community. NASA's latest engine design is built around pushing the limits of speed by approaching the very threshold of light. The core idea rests on innovative energy conversion and manipulation techniques that, at first glance, seem to defy conventional physics. By harnessing theoretical models that once belonged solely to academic discussions, this engine proposes a method to reduce mass drag and enhance thrust beyond traditional chemical propulsion limits. Such a system could potentially reduce travel time to distant celestial bodies dramatically. As researchers and engineers refine these early prototypes, the vision of near-light speed travel is transitioning from abstract theory into a tangible technological breakthrough, one that redefines the possibilities of future space missions. At the heart of this revolutionary engine lies a series of scientific breakthroughs that challenge the established framework of physics. The design integrates principles from quantum mechanics and general relativity, areas that rarely intersect in conventional propulsion systems. By pushing these boundaries, NASA's engineers are not just developing a new engine, they are questioning long-held assumptions about energy, inertia, and the fabric of space-time. Critics argue that such radical departures from traditional models require rigorous testing and may expose unforeseen challenges. Nonetheless, the promise of drastically shortening interstellar travel times fuels an ongoing dialogue within the scientific community. This bold initiative invites both admiration and debate, as experts scrutinize the feasibility and theoretical underpinnings of the design. Developing an engine capable of near-light speed propulsion demands not only visionary scientific theory, but also extraordinary engineering prowess. NASA's team has faced enormous hurdles, designing materials that withstand extreme conditions, creating systems that manage unprecedented energy outputs, and ensuring safety under uncharted operational stresses. To overcome these challenges, engineers have experimented with advanced composites and cryogenic techniques that push the boundaries of current technology. Their innovative approach includes modular testing phases, allowing for incremental improvements while continuously monitoring performance metrics. Each breakthrough in the lab reinforces the possibility that this engine could one day propel spacecraft to speeds once reserved for our wildest imaginations, setting the stage for a new era in exploration. The advent of a near-light speed engine holds transformative implications for the future of space travel. If realized, this technology could enable missions to distant star systems within a human lifetime, a prospect that reshapes our strategic vision of space. With reduced travel times, long-standing challenges like radiation exposure and resource management become more manageable, opening the door to manned missions beyond our solar system. The potential benefits extend beyond exploration. Rapid transit between planets might revolutionize how we approach scientific research, international collaboration, and even commercial space ventures. This engine is more than a technical marvel. It symbolizes a daring leap toward reimagining humanity's place in the cosmos and the very nature of interstellar travel. Despite the excitement, significant skepticism remains within both scientific and engineering circles. Critics point out that many aspects of the design still reside in theoretical territory, with practical challenges yet to be fully resolved. Rigorous testing and validation will be essential to confirm whether this engine can truly operate near light speed without violating fundamental physical laws. The debate is vibrant and ongoing, with conferences and academic papers delving into potential risks and necessary safeguards. As NASA prepares for further experimental phases, the global community watches closely, weighing optimism against caution. This dialogue not only fuels innovation, but also serves as a reminder that every monumental leap in technology is accompanied by rigorous inquiry and continuous refinement. One of the most fascinating aspects of this engine is how it leverages quantum mechanics to achieve unprecedented speeds. Traditional propulsion relies on Newtonian mechanics, where force is applied to push an object forward. However, at near light speeds, quantum effects become significant. NASA's proposed design integrates quantum field theories to manipulate energy states in ways that conventional engines cannot. By potentially using quantum vacuum fluctuations or exotic particles, the engine may reduce energy loss and increase thrust efficiency. This intersection between quantum mechanics and propulsion science could be the key to unlocking near light speed travel, but it also introduces new challenges in validation and implementation. Another critical component of NASA's design revolves around general relativity. Einstein's equations suggest that space and time can be manipulated under extreme gravitational forces. Some theorists believe that a propulsion system utilizing controlled spacetime distortions could allow for faster-than-light travel without violating physics. The near-light speed engine under development might use such principles to create a warp bubble that contracts space in front of the craft while expanding it behind. This idea aligns with the Alcubierre drive theory, which has been studied for years but remains speculative. If NASA's research can transform these equations into practical technology, the future of space exploration could change forever. One of the biggest questions surrounding this engine is its energy consumption. Achieving near light speed travel requires an immense amount of energy, far beyond the capabilities of conventional rocket fuel. Scientists are exploring alternative power sources such as nuclear fusion, antimatter, and even harnessing energy from the vacuum of space itself. While these concepts are still in the experimental phase, breakthroughs in energy production and storage could make high-speed space travel viable. If researchers can develop a method to generate and sustain such energy levels efficiently, the dream of interstellar travel may become a reality sooner than we think. Speeding through space at near-light velocities presents significant structural challenges. The frictionless vacuum of space eliminates air resistance, but even the smallest particles could cause catastrophic damage at such speeds. NASA's engineers are experimenting with advanced materials that can withstand extreme stress, temperature variations, and radiation exposure. Potential solutions include nanomaterials with self-healing properties and ultra-dense carbon composites. Protective shielding and electromagnetic deflection systems might also be incorporated to ensure the spacecraft's integrity. Overcoming these engineering hurdles is a crucial step in bringing this revolutionary propulsion system to life. While NASA's focus is on exploration, a near-light speed engine would have massive implications beyond space travel. The military could develop ultra-fast reconnaissance and transportation systems, drastically altering defense strategies. On the commercial side, space tourism and asteroid mining could become highly profitable ventures. The ability to reach distant planets or moons in a fraction of the time could also revolutionize resource acquisition, potentially making off-world colonies self-sustaining. The ripple effect of such technology would extend far beyond NASA, influencing global industries and economies. With great power comes great responsibility. The development of a near-light speed engine raises profound ethical and philosophical questions. Who gets access to this technology? Should it be limited to scientific exploration, or will commercial and military interests take control? Additionally, if we can travel faster and farther than ever before, how should we approach potential extraterrestrial encounters? These are critical discussions that must take place alongside technological development to ensure humanity's responsible use of such a groundbreaking advancement. NASA has outlined a phased approach to testing this revolutionary engine. The first phase involves theoretical modeling and laboratory-scale prototypes, focusing on proof-of-concept demonstrations. The next step would be small-scale experimental launches in low Earth orbit to study performance and stability. If these tests prove successful, larger-scale missions could follow, eventually culminating in a deep space voyage. This structured development process ensures that each aspect of the engine is thoroughly evaluated before committing to full-scale deployment. Currently, space travel relies on chemical propulsion, ion thrusters, and nuclear-powered systems. While these methods are effective, they have significant limitations in speed and efficiency. The near-light speed engine, if successful, would dwarf existing technologies in terms of speed and potential distance coverage. Unlike chemical rockets, which burn fuel rapidly, this new engine could sustain acceleration over long periods, making interstellar travel a reality. The difference in capability is akin to comparing horse-drawn carriages to jet planes, a fundamental shift in transportation dynamics. A propulsion system capable of near-light speed travel would open the door to colonizing distant planets and moons. The possibility of establishing human settlements beyond Earth could transform civilization as we know it. Mars, Europa, and even exoplanets in habitable zones of distant star systems might become reachable within human lifetimes. The challenge will not just be reaching these destinations, but also ensuring that humanity can survive and thrive in new alien environments. Faster spacecraft would revolutionize space-based astronomy, allowing for close-up observations of distant celestial phenomena. Currently, telescopes provide only indirect evidence of exoplanets, black holes, and cosmic events. With near-light speed travel, we could send probes directly to these locations, gathering first-hand data. This could lead to unprecedented discoveries about the universe, dark matter, and even the origins of life. Operating a spacecraft at near-light speeds requires highly advanced artificial intelligence. Human reaction times are too slow to handle split-second course corrections in deep space. AI-driven navigation systems would be essential for managing propulsion, avoiding hazards, and conducting scientific operations autonomously. This integration of AI and space travel represents another step toward fully autonomous interstellar missions. NASA isn't alone in the race for advanced propulsion. Private companies like SpaceX, Blue Origin, and Breakthrough Starshot are also exploring new space travel technologies. A partnership between government space agencies and private enterprises could accelerate development and deployment. The combined expertise of these organizations could bring near-light speed travel closer to reality. Public interest and support are crucial for advancing space technology. Funding, awareness, and education initiatives will determine how quickly humanity progresses toward interstellar travel. Engaging with the public through science communication, educational programs, and citizen science projects can help build a strong foundation for the future of space exploration. Even with near-light speed propulsion, long-duration space missions present significant challenges in life support and sustainability. Creating closed-loop ecosystems that recycle air, water, and food will be essential for human deep space missions. Advances in biotechnology, including lab-grown food and self-sustaining habitats, will play a crucial role in making space colonization possible. The prospect of near-light speed travel is thrilling, but are we ready for it? Beyond the technical challenges, humanity must also prepare for the societal, ethical, and philosophical implications of expanding beyond our solar system. If NASA succeeds in developing this engine, we may be standing on the precipice of a new space age, one where the stars are within reach. If NASA's near-light speed engine becomes reality, one of its most exciting applications will be searching for habitable exoplanets. Current space telescopes have identified thousands of planets outside our solar system, but we lack detailed information about their atmospheres, surface conditions, and potential for life. With high-speed interstellar probes, we could send missions to nearby exoplanets like Proxima Centauri b or those in the TRAPP IST-1 system. These missions could provide direct imaging and atmospheric analysis, helping us determine if other worlds could support human life or even host alien civilizations. One of the most intriguing aspects of near-light speed travel is time dilation, a concept from Einstein's theory of relativity. As an object approaches the speed of light, time slows down relative to an observer at rest. This means that astronauts traveling at near-light speed could experience time much more slowly than people on Earth. If a spacecraft traveled at 90% of the speed of light for a decade, it might return to Earth hundreds of years in the future. This phenomenon raises complex questions about long-term space missions and their impact on human explorers. While NASA's near-light speed engine is currently focused on interstellar travel, could it one day allow us to explore beyond our galaxy? The nearest galaxy, Andromeda, is over 2.5 million light-years away, a journey that seems impossible with today's technology. However, if near-light speed propulsion evolves into faster-than-light travel through breakthroughs like wormholes or warp drives, intergalactic exploration could move from science fiction to reality. While this remains speculative, each new discovery brings us closer to understanding how we might one day travel across the vast cosmos. Before embarking on deep space voyages, astronauts may require space stations positioned at key locations in our solar system. These stations could serve as refueling depots, research hubs, and emergency shelters. If NASA's new engine enables rapid travel, space stations near Mars, Jupiter, and even in interstellar space could be built. These outposts would allow for mission planning, scientific experiments, and crew recovery, making long-duration space missions safer and more sustainable. Another groundbreaking possibility is the terraforming of planets, transforming their environments to be more Earth-like. If NASA's near-light speed engine enables rapid transportation of resources, it could revolutionize planetary engineering. Scientists have proposed ideas like sending massive greenhouse gas generators to Mars to warm its atmosphere, or deploying large-scale solar mirrors to reflect sunlight onto frozen planets. The ability to quickly transport equipment and materials could be a game-changer in making other planets habitable for humans. Space travel at near light speeds isn't just a technological challenge, it's also a psychological one. Astronauts on long-duration missions would face extreme isolation, time dilation effects, and the emotional strain of being away from Earth for years or even centuries. Advances in virtual reality, AI companionship, and mental health support systems will be critical in ensuring that deep space travelers remain psychologically stable. Understanding how the human mind adapts to high-speed space travel is just as important as the engineering behind it. One of the most exciting and controversial theories surrounding near-light speed travel is its potential for time travel. According to relativity, traveling at speeds close to light could allow for time shifts where astronauts experience time differently from those on Earth. While this wouldn't enable travel into the past, it could allow for one-way journeys into the future. If humanity perfects near-light speed travel, could this open the door to new methods of manipulating time itself? While still speculative, this remains one of the most debated topics in theoretical physics. At near-light speeds, even a tiny speck of dust could cause catastrophic damage to a spacecraft. Unlike traditional space missions, where debris is a minor concern, near-light speed travel makes it a lethal threat. NASA and other space agencies are exploring ways to shield spacecraft using magnetic fields, high-energy lasers to vaporize debris, or deflective force fields. Without these protective measures, even the smallest object in deep space could result in mission failure. One of the most exciting possibilities is that NASA's near-light speed engine could allow us to send robotic probes to distant star systems in search of alien life. Rather than waiting centuries for signals from distant planets, we could send autonomous probes that scan for biosignatures, artificial structures, or signs of intelligent life. If we ever receive a mysterious transmission from deep space, this engine might allow us to send a response, or even a probe to investigate. As NASA continues to refine its near-light speed engine, we stand on the brink of a new space age. The ability to travel vast distances in short time frames would change everything we know about the universe. While challenges remain from energy requirements to safety concerns, each step forward brings us closer to the stars. The question now isn't whether we can reach new worlds, but how soon. The future of space exploration is unfolding before our eyes, and with each breakthrough, humanity moves closer to becoming a true interstellar civilization. If humanity adapts to life in space, near light speed travel could accelerate evolutionary changes. Extended time in microgravity, exposure to cosmic radiation, and long-duration space travel may lead to physiological adaptations. Some scientists speculate that future generations of space travelers could develop stronger resistance to radiation, altered bone structures, or even enhanced cognitive abilities due to the demands of deep space survival. This raises fascinating questions about what humanity might look like in the distant future if space travel becomes the norm. One of the most promising applications of near-light speed propulsion is the potential for space-based manufacturing. With rapid travel times between planets, we could set up factories on the Moon, Mars, or even asteroids to produce materials in low gravity. This could allow for the construction of massive space stations, interstellar spacecraft, and futuristic habitats without the need to launch everything from Earth. As transportation becomes faster and more efficient, entire industries could emerge in space. The development of near-light speed propulsion could shift global power dynamics. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.